Hi, everybody. It's Dr. Schulman, and I'm doing 2B, part two, which is basically proportions and ratios. Hopefully, it's interesting for you guys. So, this one, we're doing strategies for understanding proportionality. Last time, we were looking at a bunch of graphs for this, which was pretty cool. But today, we're going to do just a ton of proportionality questions. There's a bunch of ways to show proportionality. Remember, ratios just a like one unit where they're kind of contained, like wins and losses. So it's just games. But a proportion is like wins and losses versus wins and losses. So it's like A to B versus C to D instead of just A to B. So it's like two groups of things. I always tell my students remember ratio has that O, one O. So it's like one thing. Like literally you have one group that you're working with, while proportions got two O's. So you've got like two separate groups you're trying to look at. But they all have to be in the same unit. So let's look at some proportionality. I'm going to share my screen and obviously reach out for questions. So here we go. Here's the I'm sharing my screen. And I'm gonna open this guy. So we had it before. Here's proportionality. I'm gonna drop it to the side. Here it is, math for teachers. I said I was gonna combine them, so they're all gonna be in one. So I don't have to do a lot of copy and pasting because the only difference is this course has all the algebra ones and the other group, which we'll do next, the other group's going to have all the geometry ones. But I'm going to put them all into one thing for everybody. So no confusion. Um, so math for teachers. We're in proportionality, so I can shorten that. Shorten this. Here's 2. Here is 2B. And we're doing 2P part 2. So pretty sure I stopped right where proportion starts because it got kind of late yesterday, and I am an old man. So let's jump into it. I'm gonna log in. That's me. That's my personal email. Anybody ever wants to bother me, feel free to reach out. So we're gonna go to edit. One of edit edit one of these assessments. We're in 2B. And I'm gonna go, let's move my floating head. And we are up to, I believe, the last one we did was this one. So now we're up to just simple proportions. So let's look at these. And I also have some triangles here. I think proportions are used all the times with similar figures. So let's jump into this. Here we go. Simple proportions. Really straightforward, nice and easy. 12 over x equals -2/5. I know it probably feels like the same problem a million times, but you got to be really good. Know where students are going to make their mistakes, right? Really try to keep this in mind. So a really fun way I always tell my students is I say the thorax is the butterflies. So the equal signs of the thorax, there's the antenna. And if I have two equal wings, uh, butterfly routes are cross multiply. So this is 2 times x, which is 2x. And this is equal to 12 times 5, which is 60. And then we just divide both by 2, and we get x is 30. Now, if you want to do this the scale factor way, because I'm going to show you two ways to do them all, you could think, ready? Oh, it's negative, sorry. Glad I don't forget my negative sign. So we can think about this is 12x -2, 5. So to go from here to here, we have to multiply by a -6. To go to here, we have to multiply by a -6. 5 times -6, still -30. So either way is going to work for you. This is called the scale factor, where you kind of go across, and then this is the algorithm, where you cross multiply. And we're 1 for 1. Oh, they even showed the other way. Wild. All right, let's do a level 1 with some similar figures. Real common. So one way that you can really help your students is I like to go little, big. Then you can go, for this one, I go top, bottom. Just so my students don't get confused. So we can always have something. You can go big, little, bottom, top, top, bottom. Like, doesn't matter how you set this up, it'll always work out. So these are two, they're they're not parallelograms, they're just quadrilaterals. They're called quads, quadrilaterals, or quads for short. because they have four sides and they're polygons. That's it. So we have 17 to 26. We got 60. I'm assuming we want FG. Yeah, that's our X. So the little top, here, I'll use a different color. So the little top is 17. That's the little top. The little bottom is 26. The big top is 60 and the big bottom is X. As long as we have it straight up, we're good. Now, another way I usually show my students how to do this, I literally have them go like fraction, fraction, and then cross multiply. But either way, we're left with 17 times X, which is 17X, and 60 times 26. Now, I showed this before, so if you just want to show your students how to do this with the calculator the whole time, I don't know how comfortable you are with teaching them how to use the calculator. That's a choice you can make. But if you want them to use a calculator, you could just have them just type it into one step. So it's going to be X equals 60 times 26 over 17. That's the way to do it at once. 60 times 26 divided by 17. And we did it. 91 point, nearest 10th. So it's 91.76. So you always go one more place. I got to move my floating head again. Sorry. Bye-bye. So there's the tens place and there's the hundredths place. Because this is bigger than a 5, we're left with 91 point. What's one more than 7? 8. That's the answer. 91.8. And there we go. Ta-da. How'd they do it? All right, I like this. Theirs is fine, but I really like this chart. I think it helps students out so much. But see, you could do it the other way, right? You could do, you can make it, so we have 17, 26, 60 over X. See, that's not this one. That's this one. Either way, you get the same answer as long as you stay consistent. This chart, a little big, helps kids a lot. All right, let's do a harder one. We might as well go as hard as they want. Whoa, wild. You saw a flip? So quadrilateral is similar to quadrilateral FGHI. Find the measure of GH. So here we go. So here, this one is basically rotated and shrunk. When it's shrunk like that, it's dilated, because dilation just means it's the same shape, but it's either shrunk or grown, right? Like your eyes dilate. If it changes shape, it would be called a stretch, but we don't have a stretch here. So we have ED, BC, 56, 37. Then we have the little one, which is HIGF. There's your X and there's your 27. So we can still do the same thing. If you want to, if you like this little big, I'll do it this way, a little big, right? And we're just going to go left and right. Or you can do short side, long side, if you like that better. Short, long. See, because a lot of times you get a bunch of them, you have to match it up. So the short side is 37 on the big one. So short side, see, I always do it the other way, but the short side is 37 on the big one. The long side is 56 on the big one. The short side is X on the little one. And the big side is 27 on the little one. So little, big, short, long. However you want to make it happen. Now, it's not the way I normally do it because I like having my students do this. I would have them do it either way they want to make the fraction. 56 over 37. Oh, wrong way. 27 over X. See, that's what matters. If I have it the wrong way, I'm going to get the wrong. The sides have to match. So we were going to do it backwards this way for fun. So here, 56X equals 27 times 37. And we just divide it by 56 and we got the right answer. So that's one way you can do the problem, obviously. But, you know, if you don't like the tables, you want to just draw the pictures with the lines through them, that's fine too. So 27 times 37 divided by 56. And then we can use estimation, right? Because we want the nearest what? What do we want here? We want the nearest 10th. Okay, so we got 17.83. Always go one more decimal place. You look at this, it's not bigger than 5, 17.8. I really like the animations on this. I also love that this is a free program. Always give your students things that are free. You could always find a free piece to work. How they do it? No, they only did it one way. They did completely different than mine. But guess what? Same answer as long as you stay consistent. All right, let's see how hard we can make this problem. All right. So now I have triangles. These are called, just so you know, these are called obtuse. I'll tell you what all the shapes are every time. I guess I forgot one. There's 11, there's 23, and here is 49 and x. These are called obtuse because one angle is bigger than 90 degrees. So these are obtuse triangles. And if you want, I can show you how to find every side and angle of this thing, even though it's not a right triangle. This involves what's called law of sines, law of cosines. If you're curious, if you want to push your students harder, feel free to ask me. But law of cosines is great. It's literally a squared plus b squared equals c squared. However, because it's not a right triangle, it's c squared equals a squared plus b squared minus 2ab cosine of c. Whoa, sorry. This is the law of cosines. Just so you know what it is. And you use them for, because not every triangle's right, and sometimes you got to find stuff. And the law of sines is this guy. Sine of angle A over side A equals sine of angle B over side B equals side of angle C. Sine of angle C over side C. So those are your laws, just so you know. But guess what? We just need a side. This is obtuse, and why is it scalene? Because none of them are equal. This guy is not equal to this guy, and this one is opposite the biggest angle. So this has to be bigger. This has to be bigger than 23, whatever this side is. Just so you know. All right, so let's do this one. I'm not going to do the little, I'll just do the fast way because we've already done two of them. So I'm going to do it. Ready? Look. We're just going to go top and side. 11 over 23. Stay consistent. 49 over x. Done. That's why I show my students that it's just fast, right? As long as they're consistent. You might think it's weird because this one's over here and this one's over here, but if it's flipped and reversed, if I reverse this triangle, right? So it looks the same as that guy, it's still going to be 49 over the x that we want. Ta-da! That's why you can do it. With this little, drawing the lines in. So this is 11 times x. This is 49 times 23, and then we divide by 11. And we are done. All right, I hope that was useful. I hope you like these different methods. I'm trying to show you as many as I can, especially with these shapes. I like geometry a lot. I'm sure you got the picture. We want it to the nearest 10th. Okay, so 102.45. Now this is 5 or bigger, so we're left with, and this means similar to, or approximating. Sorry, this means approximate. If it's ever one of these, this just means same shape. Just so you know, this means it's similar. They can literally, if they say it's similar, they can use this. So for this problem, here, let me finish it first. This means we're approximating because we rounded, but they could have said triangle, get out of here. BCD, they could have literally just run it like this, is similar to triangle EFG. And notice they all have to match. B has to match to E. B does match to E. C has to match to F. C matches to F. And D matches to G. This is how they can write this out in just symbols. So just so you know, and this just means it's either shrunk or grown. 102.5. We did it. Oh, that's fancy. What? I love theirs. Theirs is actually cool. Very cool. All right, let's see what else we got. All right, so now we do some harder ones. We've seen these before, but I want to do some of them again just because they're tough. So 1,110 students at Ridgewood Junior High 4% of students bring their lunch to school every day. How many students bring their lunch to school every day? So this is the way they want you to do it. I would do it this way. I'm going to show you two ways because why not? So it's 1,100 and we want 4% of 1,100. So that's 0.04 because we have to, this is telling you to divide by 100 of means multiply. We're done. 0.04 times 1,100. It's really 1,100 times 4, 0, 0, 4, 4. I have two decimal places. The answer is 44. Here's the other way we can do it. 100, this is the way they want you to do it on this thing. 100 divided by 4 is 25. So 1,100. Whoa, I don't know how that happened. I apologize. So 1,100 divided by 4, this is the scale factor they want you to see it, is going to be 44. I believe that's what it was, and we're good to go. Two ways to solve it. Ta-da! I kind of like this way better, but it's okay. Use whatever way makes the most sense to you. I'm trying to show you all the ways. So let's make it harder. All students at Ridgewood Junior High either get their lunch in the school cafeteria or brought it from home. Tuesday, 25% of their students brought their lunch. 32 students brought their what? Oh, okay. Either get their lunch or bring it from home. On Tuesday, 25% brought their lunch. So this means if 25% brought lunch and 75% got it at school, just so you know. How many students in total are there at Ridgewood Junior High School? So 32 brought their lunch. So this just means, well, there's your 32%, your 25%, right? And we know we have 32 students. I wouldn't do it this way, but this is the way they want to show you this. So it's 25 times 4 is 100. So what is 32 times 4? 4 times 2 is 8. 4 times 3 is 12. It's 128 kids. But they want to know how many kids are in total, right? So if we know 128 kids brought their lunch, we can do something, right? All right, so 32 is 25% of X. No, don't do it that way. I think that's messing it up. So how would I reason this out if I was to show this to a student? This is 25%. So all we have to do is the other half. So if we do 32 times 4, right? So if I do 128 times 0.25, I get 32. That should be the first step. And we can double check with the calculator. 128 times 0.32. Oh, sorry. 128 times 0.25. I typed it in wrong. See? But we just need the other 75%. So 128 times 0.75 will give us the rest. Isn't that fun? I just want to show you a different way. This is the way that makes the most sense, I think, for a student. And we add them together. There's 8. And we have 128 total. See, that's the way I would do it. Wait. 32. Yeah. So either way, it's 128 students. But I like this. This is nice for me. Ta-da! Double line is really nice. I might start using it. Oh, level 3. Let's try it. Skylar made 5%. So 5% really means 5 divided by 100 or 0.05 or however you want to slice this could be 1/20. If she shot 220 free throws, so that's the total. So basically, we want what is 5% of this. So we want 5% of 220. So 0.05 times 220 When you're multiplying this, just put the 5 here. 5 times 0 is 0. 5 times 2 is 0. 5 times 2 is 10 plus 1 is 11. 2 decimal places. She made 11 free throws. That's it. Gotta get back in the gym, Skylar. Beautiful. Cool. All right. Now these are a little bit tougher. Okay. I'll try my best to explain these the best. This is like 7th grade, 8th grade stuff. So I put it in just to show you other types of proportion. I really want you to know more, just in case you have really strong students and you want to push them. So that's why there's some harder stuff in here. So X and Y vary directly. So what does this mean? This is Y equals K times X. This means if I want my constant, I have to divide by X. So this means our constant is Y over X. This means very directly. Now, if they ever say it's an inverse variation, so this is direct variation, direct. They ever say inverse, it's the other way. So this is Y equals K times 1 over X. So what does this mean? This means X times Y equals your K. This is if it's an inverse relationship, but we have a direct relationship. So X and Y vary directly. When Y is 4, K is 12. All right, so when Y is 4, X is 12, so it's K times 12. Divide by 12, divide by 12. So this means what? What is your K? 4 divided by 12 is really what? We can divide by 3. And we know it's 1/3. Oh, sorry. Divide by 4. I'm like literally doing it in my head. So it's 1/3 equals K. So what does this mean? Y equals 1/3 X. Ta-da! So we want to find Y when X is 15. So Y equals 1/3 times X, which is 1/3 when X is 15. This is a fraction. We can make this side a fraction by just dividing it by 1. Cool. So Y equals 15 over 3. I would simplify right away, but either way, 15 divided by 3 is 5. And that's the right answer. Now, is this an elementary school standard? No, but I just always want to push a little bit more. They did the exact same way. There's a constant of variation of proportionality, and we're left with Y equals 5. Now remember, if they want to inverse, it's not division, it's multiplied. It's a little tricky, but that's how it works. All right, let's see what else we got. Oh, we got a word problem. This is usually the way to do it because these are tough. So Madeline, we got our girl Madeline or Madeline. She buys 13 bottles of OJ, 13 bottles, and it costs her $5.33. Okay, so ready? Y equals K times X. My Y has gotta be, this is your input. So your input or your X value is always there. And your output is what happens afterwards. A lot of people call this independent variable, dependent variable, things like that. But either way, $5.33 equals K times 13. You got to divide this by 13. It's really 5 and 1/3. I'll just put in the calculator. We've seen enough mixed numbers. So 5.33 divided by 13. This is our constant proportionality is 0.41. We could have done it, but we stopped there. So we want to know how much is 14 bottles of the same juice. Now, Y equals K times X. Y equals 0.41, that's our constant, times 14. So we can do 41 times 14 or just 0.41 times this 14. And we know it's $5.74. Now, another way to do it, I would do it this way. 13, right? I would do small, big, however you want to think about it. 13 is 533. And then we would do 14 is X. This is how I always do it. So 14 times 533 equals 13 times x divided by 13 divided by 13. See, like you can do this every time, but sometimes they ask you for the formula, right? And that's where stuff gets tricky. So it's 14 times 533 divided by 13. We should get the same number. We should still get 574. We do. Magic. And I'll show the other way. Don't be afraid. Show the students this way. Show the students the algebraic way. Show them the cross multiply way. They'll get the same answer. 2 to go. 2 to go. Oh. All right, here's some algebra for you. 9 over x minus 8 equals 8. This is obviously a middle school standard, but who cares? We do it the same way, and it'll be nice. First step, equal sign, looks like a thorax. There's my antenna, wings. So the first one is 8 times x minus 8. The other side is 9 times 4x minus 4. What do students usually mistake? They usually just multiply the first term. They forget they got to multiply to both. The distribution has to happen to both, and then you're good to go. So let's try it. 8 times x is 8x. 8 times negative 8 is negative 64. 9 times 4x is 36x. 9 times negative 4 is negative 36. Always keep your x on the left, especially when we get to inequalities, because you're going to need it. That's a negative 24. Wait, whoa. Is it 24? Nope. Negative 28. Wow, I had a moment. Sorry, negative 28x minus 64 equals negative 36. So we got to add the 64. So it's a plus and a minus. So we're going to subtract it, and we're going to take the bigger term. So it's 28. So we're left with a negative 28x. Sorry about that. We're left with so this is going to cancel. I mean, I hope it cancels. So we're left with a negative 28x equals a positive 28. We divide by negative 28. We divide by negative 28. And our final answer is x equals minus 1. Now you can check by dropping it in. If you check by dropping it in, this doesn't work. This will happen when you see absolute values all the time. If you have to plug in a number and it doesn't work out, that means the solution is called extraneous. Isn't that awesome? But either way, we're left with negative 1. Magic. But if you were to plug this in and it wouldn't work, guess what? That's what happens. Here's the last one. Oh, thought I'd give you one hard one. See, gives you the notation. So here's our line segments. Wow. Okay. So here's the little guy, D, E, F. Here's the big guy, D, B, C. So the first thing you should do is you just separate them. There's your big guy, D, B, C. Here's your little guy, D, E, F. Now we can do it the same way, but you just have to know how to separate it. So they're saying F. Oh, okay. Wow. So they're saying FC and CD. So doing this little piece over this big side. It's the same thing as this piece and this big side. So this is FC matches. Oh, sorry, they're saying FD. Oh, I even wrote it wrong. So my bad. So when they're saying FD, that has to match to ED. They probably want a capital. And then when they're saying CD, that matches to BD. You can do it this way too. I'll do a couple of these just for fun. Those are your matching sides. You just got to see how much. Whoa, that's wild. I try to draw it. Mine's just ugly. Let's do one more of these. I was hoping them to give us some numbers, but that's okay. So WX and WV. So WX has to match to TU, and WV has to match to TV. I really like the what's it called? And then you can put the numbers in. Let's do one last one just for fun. Wild, okay. So they're saying F, this means congruent, this means equals in size and shape. So F matches to I. So F goes to I and D goes to G. So this means EF has to match to HI. Oh, sorry, they're saying EF to HI. EF matches to HI. Does it even matter? Okay, so if EF, so I'm gonna go ED. I guess there's multiple choices for this. So EF is ED, HI is HG. That's the way I would do it, but there's more than one answer, right? See, there's one, there's the other one. Ta-da! Magic. All right, I hope this was useful. This is tons of proportion stuff. And this is the end. So I hope you're excited for your quiz. This is the easier quiz, because I just feel like you just gotta get really good at cross multiplying. I threw in a couple other things for fun, but good luck. Let me know if you have questions and have a great day.